Hello everyone, welcome back to IBMathlogy, your gateway to 7 on 7 in math. So today we are covering one of the biggest topics of IB Math AAHL, that is differentiation. It is one of the important part of calculus. So what exactly is differentiation? It gives you the slope, or you can say the gradient of any curve at any point. So whenever we are talking about a curve, we know that gradient is changing at every point. For example, if I draw a curve like this, so I can see that at this point, this is my slope. But at this point, I have to draw a tangent like this. So this will be my slope. So slope is changing at every point. You can see that at this point also your slope is like this. So at any part of the curve, you can find out the slope using differentiation. So there are some symbols which we will be using for any function y or fx. My slope, gradient or differentiation will be dy by dx, or if it is fx, it will be f dash x. Now what does f dash x represents? It represents the slope. This is my first derivative because I have written f dash x. Now from this I want to find out the second derivative. So the second derivative will be d2x, it will be d2y over dx square, or we can write it as d by dx of the original curve, because from y we got dy by dx and now we have to differentiate this to get this. So we are again taking out the derivative. Now if it is in f dash x term, so I will be writing f double dash x, and it keeps on going whether we want to find out first derivative, second derivative, third derivative or nth derivative. Although you won't need to use this definition in most of the questions, but understanding it helps you see why the rule works. Now let's understand the very important rule of differentiation, that is known as power rule. So what exactly is power rule? For any y is equals to x to the power n, I want to find out the first derivative. So the power rule says I can write it as d by dx of x to the power n. Now the first thing you should keep in mind is, if you have a function in x, so you will derivate it with respect to x only. So it says I am derivating y with respect to x. You cannot take out derivative of any function that is not in x with respect to x. Okay. So the power rule says it is n x to the power n minus 1. Although it is there in your formula booklet, but when you will be solving a lot of question, you will remember this rule. So this is my power rule. Now, for example, if I say what is 5x square, so I can write my dy by dx. I can take out 5 common because it's a constant, so it will not affect my function. Now according to the power rule, my n is 2, so it should be n x to the power n minus 1. That will give me 5 into 2x. So derivative of 5x square is 10x. Now what if I again want to find out the second derivative? So I will again take 10 common and this will be dx by dx. Now since it is only written x, so it means its power is 1. So I will write again n x to the power n minus 1, which will give me 10. So by this you can remember that when you have only single power, so its derivative is a constant. Now what if I want to find out for root x. Now the first important rule is we should write it as x to the power half. Now I can easily find out dy by dx. So I will write it as x to the power half with respect to x. Again n x to the power n minus 1. Now upon simplification I will get my answer like this. But you should not leave your answer like this. X to the power minus half is nothing but 1 upon root x. So this is the first derivative of root x. Now comes the second rule. Derivative of a constant is always 0. So I can write it like this. D by dx of any constant is 0. Now the third rule is, if I am taking, let's say, d by dx of two different functions which are in either, you can say, addition or in subtraction. So you can write it like this. You can open the bracket and find out derivative of both like this, and then you can solve it easily. Now if you see your formula booklet, you have derivatives of these algebraic functions, trigonometric functions, inverse trigonometric functions. So these all are derivatives of the trigonometric functions. No need to remember these formulas. These all are there in the formula booklet, and these are for inverse trigonometric function. So this arc sine is nothing but sine to the power minus 1. It means it is sine inverse x. Similarly, this is cos inverse x and this is tan inverse x. Now there are some more formulas. Now let's take an example that I have a curve, let's say like this. So this is y is equals to x square, and I want to find out the slope at this 1, 1. So first of all, slope means this line. So I have to find I will find gradient as well as the equation of the line. So gradient means I will be taking dy by dx. So I will write y is equals to x square. So dy by dx, that is nothing but my slope. According to the rule, it will be 2x. Now they want at a point, let's name this point as P. So slope at P, it means my x value is 1. So I will find dy by dx at x is equals to 1. This is the way to write. So you have to remember this. So my slope is coming as 2. It means slope at 1 is 2. Now the second part of the question is I have to write the equation of the line. Now all of you know basic equation of a line is mx plus c. So this is my m. So I can write y is equals to 2x plus c. Now the point 1, 1 is given to me. So I will substitute it here to find out the value of c. So I will write 1 is equals to this. So 1 is equals to 2 plus c. So c will be minus 1. It means my equation of the line will be y is equals to 2x plus 1. These type of questions comes in the exam. So you should practice these type of questions. Now let's take an example. We have a function x cube plus 5x square minus 8. We have to first find f dash 1. So f dash, first we have to find f dash x, and then whatever is the answer we will put x is equals to 1 into the answer. So let me first write what is fx. So fx is x cube plus 5x square minus 8. Now I will be using d by dx of x to the power n as n x to the power n minus 1 formula. So I can write f dash x will be 3x square, 5 common, x square derivative is 2x and constant derivative is 0. So from there I'll get this as my f dash x. But now I want f dash 1 means I have to replace x with 1 everywhere. So it will be 10 into 1. So my f dash 1 will be 13. So my gradient or slope or value of the derivative at x is equals to 1 is 13. Now in the B part, find the equation of the tangent to the graph of f at x is equals to 1. So we will again be using y is equals to mx plus c, where my m is 13, but now I need to find c. So for that, x is equals to 1 is given to me. So first I have to find f of 1, because this is nothing but my y. So it will be 1 cube plus 5 into 1 square minus 8, that is 1 plus 5 minus 8. So my y value is coming as minus 2. Now I can put 1 comma 2 into y is equals to 13x plus c to find this c. So I can write like this. So my c will be 2 minus 13. So c will be minus 15. It means my equation of the tangent will be 13x minus 15. So this is the answer. Now let's understand product rule, one of the very important rule when it comes to differentiation. So we use product rule when we have two functions multiplied together. For example, I am writing y is equals to u into v. So I cannot write dy by dx as u dash into v dash. This is completely wrong. So we have to use product rule for that. So my dy by dx will be u dv by dx. First I will take u as my constant and I will take out the derivative of v, and then I will take v as my constant and I will take the derivative of u. So in simpler word, if I want to write, so I will write y dash is equals to u into v dash plus v into u dash. This is the simpler way to write the differentiation. Now how will you remember? Take first as it is, do the differentiation of second. Take the second as it is, do the differentiation of first. And it is not always necessary that we get only two functions. We might get u, v, w also. Then also, if I want to write y dash, we will take first 2 as constant, derivative of third one. Then you can take first and third constant, derivative of the second one, and then second and third constant, derivative of the third one. So like this we will find out the derivatives when they are in multiplication. Now let's take an example. So for example, I am saying y is equals to, let's take x cube into sin x. Now as we know that these are two functions which are being multiplied, so you can assume anyone as u, anyone as v. So once you have u, you can find out u dash, that will be 3x square according to the power rule. And when you will look into your formula booklet, derivative of sin x is cos x. Now my y dash will be uv dash plus vu dash. So y dash will be, my u is x cube, v dash is cos x, plus v is sin x, u dash is 3x square. So if I want to simplify this, I will write x cube cos x plus 3x square sin x. So this is my derivative of the given function. Now you can try this example. Y is equals to, let's take x square multiply by e to the power x. So you can try this and you can put your answer in the comment box. Now let's take another example. Y is equals to x square into ln x. Again I will take this as u, I will take this as v, and I can write v dash as u as it is, derivative of ln x is 1 upon x plus ln x as it is, derivative of x square is 2x. So this will give me x plus 2x ln x, or I can take x common. So this is my y dash. But what if I change this question to y is equals to, let's say, 2x plus 1 whole cube multiplied by ln x. Now you cannot directly apply product rule in this. So for that, we will use chain rule. Now you must be wondering why we are using chain rule. Because this time instead of x you have a function. Let's understand this simply. So if I am saying y is equals to any x to the power, let's say, cube into the same ln x. So this is a x, not a function, but what this is it is function to the power cube multiplied by x. So whenever instead of x you have fx, so we will be using chain rule. Now what exactly is chain rule? Let's take 2x plus 1 whole cube as u. So my u dash will be, I will again be using power rule, 3 into 2x plus 1 to the power 3 minus 1, but this time I have to take out derivative of my fx. So this will give me 3 into 2x plus 1 square, derivative of 2x will be 2 and constant derivative is 0. So this time my u dash is 6 2x plus 1 whole square. Now you must be wondering why I am doing this. So let's understand this. For this, if I am saying y is equals to x to the power n. So my product rule, power rule says it is n x to the power n minus 1. But what if I have any function to the power n? So my derivative again will be using the power rule. So it will be n into fx to the power n minus 1 multiply by the derivative of that fx. Now why we were not doing in this? Because derivative of x which is given to me is always 1. So that is why I simply write it as like this. I hope you understand. This is the most important and most crucial part of doing differentiation. Students get confused a lot, so you please understand this very carefully. Now let's solve our question. So my question was y is equals to 2x plus 1 whole cube ln x. If I take u as 2x plus 1 whole cube, so my u dash was 3 into 2x plus 1 to the power 2 multiply by 2, derivative of this fx, and I am taking my v as ln x, so v dash will be 1 by x. Now I need to simply write uv dash plus vu dash. So my u is 2x plus 1 whole cube, v dash is 1 upon x plus v is ln x, and my u dash is 6 into 2x plus 1 whole square. So now we can simplify and write it like this: 6 2x plus whole square into ln x. So this is my y dash. So I have used product rule as well as chain rule in this. Now these above examples are for multiplication of any two functions. What if I say my y is, let's say, u upon v? Functions can be in division also. So for this I will be using quotient rule. This is also there in your formula booklet. So from there you can see that the one and only thing which you need to remember is we need to keep the denominator as it is. So vu dash minus uv dash upon v square. And if you don't remember, you can always look back to your formula booklet. So you will get this as your formula. Now, for example, I have y as, let's take sin x upon x square, a simple example. So my u is sin x, so u dash will be cos x. My v is x square, so v dash will be 2x. So now if I want to find v dash, so I will use this formula. It says v u dash minus u into v dash whole divided by this. So this is my derivative using quotient rule. So you can try the questions. Now for quotient rule, it is not always necessary that you solve the question using quotient rule. We can convert the division into multiplication and then use the product rule instead. Some students find it easier. For example, if I write it as sin x into x to the power minus 2. Now you can assume it as u, you can assume it as v. So your derivative will be the same. So it's up to you whether you want to use quotient rule or product rule by converting the quotient or fraction into the multiplication. So that's all about first part of differentiation. So you have to remember some golden rules which are very important for you. The first one is convert first, means you should change roots and fractions to index before differentiating. For example, I am saying cube root x. You first write it as x to the power 1 by 3 and then apply your differentiation formula. The second is chain rule. Any composite function is always derivative of outside into derivative of inside. So we just did 2x plus 1 whole 4 or whole cube. So derivative of outside is applying power rule and then derivative of inside. The third one is we studied product rule, quotient rule. So you can convert the quotient into product. So in the next video we will be covering implicit functions derivative, parametric form, some stationary points, optimizing the function and some connected rates question along with some GDC hacks which you will be using in paper 2. If you have any doubt or any concern, you can always put your doubts and you can put your comment below in the comment box. Subscribe and hit the bell icon for weekly IB Math video. Have a great day everyone.